So today we're talking about proving triangles similar. Not congruent anymore, but similar. So I think Ms. Trace already talked about this, but we use a little, just the top part of the congruent symbol expresses similarity. So we're going to learn how to prove triangles similar. Let's get the similarity postulate in our notebook. And I'll give you a second here as I talk through it. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Sorry. So we've got two triangles here, and we have angle J congruent to angle X, and angle K congruent to angle Y. So that's all we would need for this. Instead of like where we proved triangles congruent, we needed three things. For this particular postulate, we only need two. We don't need the third one because we would already know that those are congruent by, I think, what's called the triangle sum theorem in our book. So, and then you have to make sure to state the similarity statement with the vertices in the right place. So it's J, K, L similar to X, Y, Z. So let's go ahead and apply this. And I picked just one problem from the book that I thought was maybe the trickiest. And this is actually, it's called Guided Practice number 2. It's on, I think, the second page of the lesson. And it set the directions for this. They show that the triangles are similar and write a similarity statement. And we have this drawing, and they want us to talk about triangle CDF and triangle DEF. So something that is helpful, I think, is to draw the triangles out separately with what we know. So here's triangle CDF. That's where we have the right angle here and the 32 degrees up here. And then let's draw this somewhat smaller triangle, trying to keep the corresponding places in the same place. This is DEF, and here we've got 58. And we can prove this similarity or write our similarity statement using a couple things. If this is a right angle and this is 90, this is the linear pair postulate says this has to be 92. So this is a right angle. The sum of these is 138, so the third one has to be 32, and so we have enough to say we've got this one and this one, and that's all we need to prove the triangle's similar. And a similarity statement is just this: CDF similar to triangle DEF, making sure that the corresponding vertices are listed in the same place. It's tough because we're reusing some of the letters, but so C and D are in the right place. D and E, F and F. So there's one example from your book about how to apply that to those triangles. And then I'm just going to add a couple proofs into this lesson. We gave you a sheet, and I'm going to do the first two on that sheet, and we're going to do the other two in class. So let's do a few proofs. All right, so in this diagram we have it given that angle A is congruent to angle D, and angle 2 is congruent to angle 4. And we want to prove triangle ABC similar to triangle DEF. I have one angle, I need a second one. So let's write down our given information. We can put these in the same step. Okay, and then we can state that angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary. And let's just put definition of supplementary here. If I know that these are supplementary and these are supplementary, it looks like 1 and 3 are supplementary to a pair of congruent angles. Hopefully that is sounding familiar because we learned that earlier this year. I can go ahead and say angle 1 is congruent to angle 3. It was called the congruent supplements theorem. So if a pair of angles is if a pair of angles is supplementary to a pair of congruent angles, then that pair of angles are also congruent. And now I've got, I guess let's go like this. I've got two pair of congruent angles, and I can prove the triangle's similar. A similarity, we can just go like that. And just like before, we're going to go ahead in parentheses and put where did I have my two pairs of congruent angles. I had one in the given, and then I had one here in step 3. All right. Jumping down to the second proof. Now I know that line HM is parallel to segment JK, and I want to prove triangle GHM similar to triangle GJK. So I'm going to once again put down my given. And hopefully you remember way back when we looked at parallel lines and relationships between angles and parallel lines. So I can, and I'm going to put them in the same step, I can show that angle 1 is congruent to angle 3 and angle 2 congruent to angle 4. And that's the corresponding angles postulate. Those are corresponding angles on a set of parallel lines, so they're congruent. And I already have my two congruent angles. I've got angle 1 congruent to 3 and 2 to 4. So I can go right to the similarity statement. That's the AA similarity postulate. And here I've got, they're both in step 2 because we didn't break them out. And we'll practice some more proofs in class.